Okay, so in this demonstration what we're going to do is we're going to explore areas using a rectangle. Now we already know that the inside area, the amount of space that the rectangle takes up, is given by the length times the width. Well, you know that already. Now for this demonstration what we're going to do is we're just going to rename those sides to base and height, and you'll see why later. But basically this fits in with the formulas for parallelograms, triangles, rhombus, kite, and so on. So what we're going to use is this idea here. So we still have then that the area inside the rectangle is now base times height. Hasn't changed anything, just changed the names, that's all. Right. So here we're going to do. What we're going to do first is we're going to look at how we could change that into a parallelogram. So we have a rectangle. It's got a certain height and it's got a base. So what could you do to make that into a parallelogram shape? Well, one of the nicest tricks is to do something like this. Just draw a line which cuts off a triangle. That little triangle section is going to be placed on this end here. This is what it looks like. You end up with a little triangle section on the end, of a shape looks like that, and you can see now how that would form a parallelogram. But if you look at that, what can you say about the area of the original rectangle and the area of the new parallelogram? Correct. Yeah, they're both the same. They're exactly the same area. Now notice what we've got. This is the height, not the sloping side. Not that. That is not the height. The height that we're talking about is the perpendicular height, the straight up and down height, the height that's at 90 degrees. So the height that we've got there, and notice the base hasn't changed. The length of the base is the same. So the area of a parallelogram must be equal to the base times the height. It seems a little surprising, but the area of the original rectangle and the area of the new parallelogram are identical. So what we have here is the same formula for both parallelogram and rectangle. Now the reason is we're not to take any notice of the actual slanting side. The height is the perpendicular height, the height that goes straight up. So cool, we've done it. We found the area of a parallelogram. Now, moving on. How could we find the area of a triangle? Well, let's have a look. If we start with a rectangle, which has a certain base and a height, how could we cut that to make two triangles? Correct, well done. So in this case here we could cut like that. Notice we get a right angle triangle. So this now gives us the fact that the triangle that we have, well, how many triangles do we need to make a rectangle? Okay, so two triangles equals one rectangle. So therefore the area of a triangle must be equal to half of the area of the rectangle. So in other words, this is base times height. Get that answer and then half it. In other words, divide it by 2. So the area of a right angle triangle comes directly from the rectangle. Okay, because two triangles make a rectangle, so a triangle must be half the rectangle. Now that's all well and good, but if you chop a rectangle in half or a square in half, you're always going to get your right angle triangle if you do it this way. But we have just seen that using the idea of a parallelogram to start with, we can actually cut that one to make triangles again. So in this case, there's our base, but remember, with a parallelogram, that is our height. So let's have a look. That then turns into our triangle. Oops. Right, just change the back. That changes into our triangle, which looks like that, and is not necessarily right angled anymore. But look what we've got. That's the height, and again, that's that perpendicular height, the height that goes straight up and down. Here's the base. Okay, so we have a base, the perpendicular height. But what is the area of the original parallelogram? Well, from what we saw before, the area of the parallelogram is base times height. So the area of this triangle, area of a triangle, and the difference is it's not a right angle triangle, so this is any triangle. Okay, the area of a triangle now is the parallelogram area, which happen to be the same, but we only want half that. So in other words, we've now got the area of a different shaped triangle. It's still the base times the height. Okay, so what we've done, from our basic rectangle, we've renamed it into base times height, and once we've got our base times height, we've then played with it, explored it, cut it, changed it, chopped it, whatever you want to call it, so that we've now arrived at two different formulas. One for a parallelogram, which is base times height, and then one for any triangle, which is base times height. Get that answer and then divide it into two. Okay? Done.